All right, this video and the next one are going to go through some concepts related to work. So we're not calculating anything quite yet, but we will do some examples with calculations as well. So as usual, pause, decide what you think the answer is, and return. All right, so the correct answer here is A. So it helps, let's go back, free body diagram it. We know there's a force of gravity downwards. We know Albert's hand, I'll call it force sub A for the force of Albert's hand, pushing upwards. It does tell us, It does tell us that this book is moving downward at a constant speed. So this question is specifically asking us the work done by the force of gravity. So work. Albert's force has to equal the force of gravity in order for this speed to stay constant. So this you should conceptualize from the previous section. Constant speed means no acceleration. That means no net force. These forces have to balance each other out. Now, to move forward into this concept of work, the force of gravity is constant. We have our generic equation for the force dotted with displacement for a constant force. We can write this also as the magnitude of the force, the magnitude of the displacement times the cosine of the angle between them. So when we're talking about any one of these, the work done by gravity, I'm going to write that as W sub G. Work done by gravity will be the force of gravity times the delta Y, because that is the direction the object is moving in. And when we leave this cosine of theta, I find it can be helpful if we go ahead and draw these two vectors starting from the same point. So force of gravity points downwards. The direction the book is traveling in is also downwards. So theta in this equation is 0 degrees. Those two vectors are in the exact same direction, so there is no angle between them. So the work done by gravity will be the force of gravity, mg, delta y, the distance moved, so the h, the cosine of theta, when we put in cosine of 0 degrees, this is positive 1. It's this cosine theta term that determines the sign. This is why the work done by the force of gravity is positive. The force of gravity and the displacement are in the same direction. Anytime we have a force and the displacement in the exact same direction, the work is going to be positive. Because, well, we know the force of gravity is trying to speed that book upwards. Now, the question is not specifically asked, but what about the work done by Albert? We know Albert Einstein is applying an upward force, but we know the book is moving down. So the angle between these two is 180 degrees. So the work done by our friend Albert would be the force he is applying times that distance moved, the vertical distance h, times the cosine of 180. This is where we get a negative 1. So Albert is doing negative work. That means he is removing energy. He's not allowing the book to speed up as fast as it would if it was just under the influence of gravity. So that's what we mean by negative work. He's resisting the motion, not allowing the book to speed up as much as it would without his force. Positive work means the force of gravity is adding energy to the system, putting energy in, trying to speed it up. Now we are going to be looking at a relationship between work and motion, and it's the net work or work subnet that is going to directly relate to the motion, which hopefully makes sense. It was the net force that determined the acceleration of an object. So it would make sense that if work is related to forces, then the net work should be related to the motion. In this case, what we mean by net work is the work done by gravity plus the work done by Albert. I just called that A. These add up to be zero in this case, right? We said these two forces had to be equal in magnitude because of this constant speed. That means gravity, the force of gravity, is putting energy into the system as Albert's force is pulling the same amount out. So the net work done is zero, meaning there's no change in the motion. It means that constant speed. Okay, we'll talk later about the specific equation for this, but for now, I wanted to kind of cover the concepts of those forces individually and the work they do.